All right, we're going to go ahead and continue with the final exam sample. Did version A yesterday, so we'll do the version B for today. Now, all of you guys should have received your corrected test 3. So what you can do is go ahead and see what your overall score is in the class. So before I do this problem right here, I just want to talk about how you would calculate your grade. And so I'm going to open up a blank page for us here. I just want to show you, because I always get questions, what do I have to get on the final exam to get whatever grade it is that I'm looking for? And so we'll go ahead and open up a blank page and show you that. So with this, this is how you would want to do that. So right now, the score that's in my open math is giving you 70% of your overall score. So what you're going to do is you do 0.7 times my open math. That's the score that's currently showing in the gradebook now. And then we have plus 0.3 times the final exam. Okay, and then this is going to give you the overall score. So this is the formula that you can use to calculate your overall grade. So you already know what the MyOpenMath score is. That's the one that's in there. You should go with, sometimes it shows like 2 different percentages in there. It shows a lower percent and an upper percent. You should go with the whatever the lower one is. It's probably the it's the one has to do with things that are left to grade yet and things that are not left to grade. So go with the lower score of the 2 if there are 2 different scores in there with that, like past due and something like that, it'll say. So if you go with that lower one, put that in here. And then for the final exam, if you're looking for what the highest possible grade is you can get in the class, then what you would do is put 105 in for the final exam. Remember, we've got our bonus review assignment that's still open now, and it's going to be open until tomorrow evening. And so if you're looking to boost your score in any way, or if you're concerned about getting a higher score, you want to do the bonus review assignment because there's no extensions on that. So that's due tomorrow night, 11:59 p.m., the same time that the final exam is also due. That's going to give you a possibility to add 5 percentage points to your final exam score. So that's really important to go ahead and do. So you can, if you do that and you get 100% in the final, you can put 105 in for final exam, and that's going to tell you what your overall score is. Now, if you're looking to go for a certain score, like for instance, if you want to know what's the minimum I need to get in order to pass, 70 in my class, that's the minimum percentage to pass. So what you would do then is you would just solve this equation, 0.7 times the MyOpenMath score plus 0.3 times X, and that's going to give you a 70. Or you can put 80, 90, whatever you want. Now, if you want a solid A, then that's got to be 92% or higher, since I do grade in a plus minus scale. The only score I don't give a -1 for is for a C. I don't give C minuses in class, so the C goes all the way down to 70% would be the minimum amount that you need to pass. So you could just solve this equation, and that's going to tell you what you have to get on the final exam. Of course, that score would include the bonus. So if you do the bonus and got all that correct, then you can just subtract 5% from whatever that percentage that you get here, and that would tell you what the minimum amount is you would need in order to pass. So just wanted to talk about that a little bit, and so that gives you an idea of how you would calculate what your overall grade is going to be in the class based on that. If you have any questions on this, of course, email me as usual. So with that, let's go back to the review now. All right, so we're continuing with version B all the way through. So you want to make sure you know how to do both versions on here. Okay, so version B is another one where we want to use, this is a little bit different than the one we did before. The one up above here, we had to use the slope formula. But now it's a little bit different. So we want to make sure, again, you know how to do both version A and version B on this one. So it says, find the equational line in slope-intercept form that it's perpendicular to this one and passes through -2, 5. Well, we're going to take the original equation here, And we want to first solve for y to figure out what the slope of the original line is. So that way we know which one to make this perpendicular to. So we're going to do negative 3y equals negative 2x plus 4. And then we want to divide everything by negative 3 because we want to get the y by itself. Negatives will cancel out here. Negative 2 over negative 3 will give you a positive 2/3 x. And then don't really care about the b value here. We only care about the m value. So 2/3 is the one that we want. So perpendicular to 2/3 means that we have a slope of opposite reciprocal slope. So negative 3/2. You flip the fraction and make it opposite sign. So my new line has to have a slope of negative 3/2. So now I'm just going to use the point slope formula. And I have x1 and y1 is given right here. That's this negative 2,5 point that was given. So we'll put that in. Y minus 5 equals m is negative 3/2. And I have x minus negative 2 will give you x plus 2 there. So now, because it wants slope intercept form, you want to solve for y. Negative 3/2 x. Negative 3/2 times the 2. The 2's will cancel. You'll get negative 3. And then just add 5 to both sides. Your final answer is going to be negative 3/2 x and then plus 2. And that would be your answer in slope intercept form. This means it's y equals mx plus b form there. For 2b, we have a couple different functions that we had yesterday. So we'll take a look at these for finding, we want to find domain of each of these, and then we want to find f minus g of 1. So part 3 is either going to be an f plus g or f minus g. They're both very similar in how you would do that. Let's do the domains first. Now this, if you have a fraction like this, remember that the bottom cannot be equal to 0. Okay, so we have x squared minus 9 is not equal to 0. And then we can factor it. X plus 3, x minus 3. We'll say not equal to 0, not equal, we need here. So I know that x plus 3 is not equal to 0 and x minus 3 is not equal to 0. If you move things over, you get x is not equal to negative 3 and x is not equal to 3. So now I know that negative 3 and 3 will cause division by 0. So these numbers are not included in our domain. So then what we're going to do is we're going to not include those in our domain. Now, the way that this is going to work is it's going to include all the numbers before negative 3, between negative 3 and 3, and then greater than 3. So here's what it'll look like. Negative infinity to negative 3, negative 3 to 3, 3 to infinity. Everything except for negative 3 and 3, and that's how you would show that there. For part 2, we've got so this time we have a square root that's on the bottom. Now, yesterday, what I talked about was if you've got a square root that's on the top, like this previous problem was, it was on the top, you're going to use a greater than or equal to. You also will use greater than or equal if there is no number on the bottom. Of course, you can always write a square root over 1, and then so technically you'll always have a square root on the top, but you're going to use greater than or equal. This time, though, we have to use, we're going to do 11 minus 5x is just greater than 0. We're not going to include the equal sign this time because we don't want to have division by 0. So that's why this time we use the greater than symbol only. Now you're going to subtract the 11 to the other side like that. Divide both sides by a negative. Now when you do that, the sign's going to flip, and you're going to get positive 11/5. Okay, so whenever you take an inequality and you multiply or divide by negative, the sign switches. So this is going to be negative infinity to 11/5, but the 11/5 has to have a parenthesis on it, not a bracket, because we're not including the 11/5. Then we have f minus g of 1. Now, this we're going to find f of 1. This is really the same thing as f of 1 minus g of 1. Okay, so f of 1 minus g of 1. That's what it means. So f of 1 is going to equal 1 minus 4 over 1 squared minus 9, like that. So we're just going to work this out, and we'll get negative 3 over negative 8, which is just positive 3/8. And now let's find g of 1. Okay, g of 1 is 8 times 1 minus 3 over the square root of 11 minus 5 times 1. You get 5 over the square root of 6. And so when we subtract those, don't worry about common denominators, and also don't worry about rationalizing denominators. So if the answer is something like that has a square root in the denominator, my open math would take that as an answer. Of course, it's possible you might have a whole number as well instead of some fractions and square roots, but at any rate, if you have a square root on the bottom, don't worry about rationalizing it. Okay, so that's your exact answer. You don't want to do a decimal or anything. Make sure you get the exact answer. 3/8 minus 5 over root 6. Difference quotient. So we're using the difference quotient formula that we see here. Let's off to the side. Let's find f of x plus h first. We want to put x plus h in every place we see an x. So there's two different places we have to put that in, the first one and the second one. Order of operations says that we have to do the exponent before we do multiplications. That's why you can't multiply 3 inside there. Instead, you're going to do x plus h times x plus h. So remember, there's a middle term that you're going to get when you multiply those together. It's the FOIL method, x plus h times x plus h. Now this, I'm actually going to distribute the minus signs of both of these and at the same time divide by 5. So what we're going to get here is minus x over 5 minus h over 5. So the negative distributes, and then we divide both of them by 5. We're doing that purposely because when we put this back into the step later, we'll be able to cancel out the x over 5 that's here. So that's the reason why we're doing that. But we are going to do one more step. We're going to multiply by 3. 3x squared plus 6xh plus 3h squared minus x over 5 minus h over 5. Okay. Now we'll put all this back into the difference quotient formula. So I have to write all this out again right here. So this part is the x plus h, f of x plus h. We have a minus sign, which is this minus sign, and then we have 3x squared minus x over 5. All that now is going to be divided by h. Okay, so f of x plus h is this whole big thing here. Minus sign is part of the formula, and then f of x this is all f of x right here, this part. Okay. Now we need to simplify this by canceling out some terms. So what's going to happen is when you distribute the minus sign, you get negative 3x squared plus x over 5. You want to make sure you do that step and you distribute that. Okay, so when we do that, that allows us to cancel out the 3x squares cancel out, and the x over 5, those both cancel out. Now what you're left with is these three things that all have an h that's in common. So we'll pull out an h, 6x plus 3 minus, and that's going to be a 1/5 we have left here, because that's like a 1/5 times h. So if you pull out an h, it's going to be just a 1/5 here. H's are going to cancel. Your answer is 6x plus 3 minus, actually that's going to be, this is a squared here. I forgot the square on that. So there's actually an h left over here. Yeah, so 6x plus 3h minus 1/5 is the correct answer. Yeah, I lost my square. Square was originally here at that point. So putting it back in, if you pull out an h, there's one h left over inside. There's no special notation for this. You're just going to write it out as is. You just type that in as your answer. Next one, 4 part B. All right, so x plus 1 over 4 over x. What makes this problem different than the one we did yesterday? So the one we did yesterday has 2 vertical asymptotes. This one's only going to have 1 vertical asymptote. So it's done a little bit differently than the one that we did yesterday. But again, you should know how to do both kinds. The actual problem you'll have in the final will either have 1 or 2 vertical asymptotes. So that's why you want to make sure you got to know both of those. So no matter what version that you're given, you'll know how to do it. All right, intercepts. Okay, intercepts for this, it doesn't matter what it is. If it's a rational function, you always do the same process. So for the x-intercept, you're going to take the top and set it equal to 0, x plus 1 equals 0, so x equals -1. And we'll write that in coordinate format here, so -1 comma 0. Y-intercept is you put in a 0 for x. Okay, so the f of x again is the same as a y, so we'll do 0 plus 1 over 4 minus 0. That gives us 1/4. So that's going to be 0 and 1/4. Find the asymptotes. Okay, so the, oops, I don't know what happened there. It jumped. Okay, so we have VA. You're going to take the bottom, set the bottom equal to 0. So 4 minus x equals 0. And so if you add the x to the other side, you get x equals 4. There's only 1 this time, because that's all you have on the bottom. X equals 4. For the HA, we have some rules here. Now, if we look at this original one, the highest power on top is 1. The highest power on the bottom is also 1. So this is going to be an example of rule number 2. Now, if you have rule number 2 here, you want to use, this is where the n equals m is rule number 2. When that happens, when the highest power on top equals the highest power on the bottom, you're going to divide, and we have a of n over b of m like this. So we want to divide the leading coefficients. In this case, there's a 1 on top in front of the x there, and there's a -1 on the bottom. So we're going to have 1 over -1, which means that y is equal to -1. Okay, so it's just the ratio of the leading coefficients. There's a 1 in front of this and a -1 in front of that. That's how you get -1 as a result for the horizontal. Now for the rest of it, we have to, we're going to plot all this information down here, and we'll answer all these questions. The x-intercept was -1 comma 0. So we have that. 0 and 1/4 is about right there. We have a vertical at x equals 4. And we have a horizontal at y equals -1. There's only 1 vertical asymptote here, which means the difference is we don't have a middle thing to worry about. So now we just have to see if the line is above the dotted line or below the dotted line, like that. Same thing on the end here. It's either going to be above or below. Now, what we can tell here is since we got 2 points that are sitting here, that tells us the graph has to be in this section. So I know that the graph is going to look like this. Okay, so that's the first part of the graph is going to look like that. Now, the other one down below can either be above or below. But if we notice, we only found one x-intercept, and the only x-intercept was here at -1. So that means the graph does not cross anywhere else over here. So the graph couldn't possibly be coming down and being drawn above the dotted line, because that would mean that it would cross the x-axis somewhere, and we know that's not possible because we only got one place where it crossed. Therefore, we know the other part has to be below like that. So you have one above and one below. So these are a little bit easier to graph if you only have one vertical asymptote, because most of the time they don't even require a test point. This one, we didn't have to test anything. If you wanted to know for sure whether the graph on this side was above or below, we could certainly test a value. For instance, I could just test, just to show you what would happen here. Let's test x equals 6. Okay, just any number. I could have used 5 or 6, doesn't matter, but let's use 6 in this case. So I want to put this back into the original equation. So I have y equals 6 plus 1 over 4 minus 6, and you get 7 over, so you get -7/2. Okay, so -7/2, which means you get the 0.6 and well, it's -7/2. If you turn it into a decimal, it would be -3.5. So 6 and -3.5 means the graph actually, my drawing is a little bit off, so probably it would be more like this, what it looked like. Okay, so if it would cross at this point. Still, though, that tells us the graph is below the x-axis there, and that's the main thing we want to look at here. So we could use a test point if we wanted to. Now this one, it says, does the f cross the horizontal asymptote? Now this time we're actually going to say no. So that's a difference from the previous one too. The one we did yesterday, if it has 2 vertical asymptotes, then more likely than not, you'll have it crossing over the horizontal asymptote. But this time we have no. All right, so we want to find the domain and the range. The domain is all values except for the vertical asymptote. So it's going to be -infinity to 4, and then 4 to infinity. Okay, so that's going to be your answer for the domain there. And now we got the range. Now this time we said that f does not cross the horizontal asymptote. Now because it doesn't, that means that this y value has to be excluded from the range. So that means that I have all numbers except for -1. -1 is not included because the graph is never going to actually reach -1 because we have a horizontal asymptote here. And we also know the graph does not cross the horizontal asymptote. So because of that, that's why we know that the range is all y values. It goes up and it goes down, of course, but we don't include the -1 there. So that's one thing you want to be careful of. They're easy to graph, but then you got to be careful with the domain and the range when you do these. Okay, for 5b, another one, like I mentioned yesterday, these type of piecewise functions might have 2 or 3 equations in it, but you don't have to graph them. You're just using plugging in values and evaluating. That's all you're doing on these. To do this, you look at the number inside the parentheses and you want to match it up with which of these conditional statements does that number belong to. So first thing is that 5, I know 5 is not less than 0. So that's no good. Doesn't use the first one. This one, the 5 is not between 0 and 3, so it's not the second equation, so it must be the last one. X is greater than 3, so yes, 5 is greater than 3. That tells us that we're going to use the third equation. So we're going to do -3 minus 3 equals -6. So we're plugging the 3 into the x right here. -3 minus 3, that's where -6 comes from. Okay, now the 0 is not included on the first one because we have less than 0, but not the equals. However, it is included on the middle equation. So 0 is included there. So in this case, there's nothing to plug in. It just says that if I have an x value between 0 and 3 with 0 included, my answer is just going to be -4. So there's nothing to work out there. There's nothing to plug in. It just says automatically your answer is -4 as long as your x is between 0 and 3. -3 would be less than 0, which means we're going to use the first equation. So absolute value of -3, absolute value will always give you a positive value, and that's your answer. Six is a graphing question. We did one of these yesterday, so we'll do another one, another different graph provided here. Again, you want to read values off of a graph. So this says find f of -1. -1 is here. We go down to where we hit the graph and we see that we're at -2. So -1, actually we just put the y value here only. So that's going to be just -2. Okay. -2 only. X is -1, y is -2. Solve for x if f of x equals 2. All right, so 2 would be a dotted line going across like this. So you want to read the values from the graph at each place. Now this first one, this is a -6. So actually we have two answers here, -6, but then the other one crosses here. If we go down, that's about -1/2. So we have -6 and -1/2. Those are the two x values. So when you have something like this, the number after the equal sign is always the y value. So essentially it's saying, where does the graph hit the line y equal 2? So that's why it has two places, one at -6 and it has another one here. Okay. Find the coordinates of the relative max. And the max is where you have an increasing and you have a decreasing part. The 6 up here, that's not your answer because you don't have a decreasing part that comes afterwards. Also, 6 is the absolute maximum, but not the relative maximum. That's a difference there. The absolute max is the highest point on the entire graph, but the relative maximum means you're going up and you're going down. So in this case, we're actually going to put 2 right there. So I'm sorry, the coordinates I got to put. So the coordinates are going to be -6 and 2. Okay, so -6 and 2 you have right here. All right, so that's the x value, and that is the y value is 2. All right. Okay, next thing is intervals of increasing. Apologize for my dog barking. I don't know what she's barking about. Nothing as usual. Okay, so increasing, you're looking as you move from left to right, looking for part of the graph that is going uphill as you move from left to right. So here's one part that's going uphill, and here's another part that's going uphill. Now, the mistake that I usually see people making here is they'll put increasing, okay, increasing is going to be from -8 to -6. But be careful here. It's not going to be -8. The graph doesn't stop at -8. Okay, that's the end, that's the edge of the graph, but see there's an arrow that's there. So the graph keeps on going down that direction. So because of that, this is -infinity to -6 we have to put here. So if the graph keeps going like that, you don't, in order for it to end, you have to see a closed dot or an open dot. If you don't see that, if you see a solid line continuing, or if you see an arrowhead like that, that tells you the graph keeps going off the page or off the graphic there. So that's why we need -infinity in that spot. Now the other place, it does have a defined part here, so that's going to be specifically between -1 and 0. Between the x value -1 and the x value of 0, the graph is increasing. Now again, we're going to put parentheses on all these because at that point, there's a transition between whether it goes flat or whether it's decreasing. And so parenthesis means at that point at the ends is not included. At that point, it's not either increasing or decreasing at these spots right at the top there. Decreasing is where it's going down. We actually only have one spot here where it's decreasing, and that's going to be between -6 and -4. All right, and then finally we have it's constant. There's two places where it's constant. We have one flat part here between -4 and -1. Sorry, -1 here. Okay, between -4 and -1. It's going to be flat, but it's also flat from 6. Again, that's going to go to infinity because we see the graph keeps going and there's an arrow indicating it keeps on going there. So it'll be -4 to -1, and then from 6 to infinity. That's where it's going to be constant. All right, so 7 is our quadratic problem. So quadratic equation, some kind of quadratic function will be provided for you. It'll be drawn. All right, so we want to see if this has a min or a max. Well, if it's opening up, we can see here at this point, there is going to be the absolute lowest point on the graph. So we know we're going to have a min. So we want to know if it's find the min or max. Okay, so that value here, that's at -3, because these are all in terms of units of 1. So that value itself is going to be -3. So when you indicate the min or max value, that's always the y value that you put here. Now the coordinates for that, you're going to put it in the vertex position. So -3, -3, that's right here. We'll put for the for this. Okay, so -3, -3, that is the vertex. Okay, so that's how that point gets used. So you see these three things all have to do with the point that's there at your vertex. So the vertex is the lowest, that's why we have a min. But if it says min or max, you're just going to put the y value itself there. Then the vertex means we put the x and the y value. The x-intercepts, you can read those off the graph. One goes through 0, 0, and the other one goes through 1, 2, 3, 4, 5, 6, so -6. -6, 0. Okay, so that's the two x-intercepts. The y-intercept is also going to be at 0, 0. Axis of symmetry is x equals the x coordinate of your vertex -3. It's there. And this, oops, there looks like there's some kind of there should have been an extra space here. So somehow the printing didn't come out right with this. So there should be a space between here. It's all right. Domain is going to be from -infinity to +infinity because all quadratics will have that, -infinity to +infinity. The range is the lowest y value to the highest y value. So the lowest y value, we already mentioned that before, was -3. Now this is going to be a bracket, okay, because there's a solid line that's there, so that's included on the graph. So we have to put a bracket, and that's going to go to infinity. Okay, it's lowest to highest, y values only. All right, so now we want to write the equation. Okay, so I have, first of all, the vertex. This is the h, and this is the k. So when we write this out, actually, let me change this to a y instead. Y equals a times x minus h squared. So here is plus k. All right, so I wrote that out with a y in it. Next, what I'll do is I'm going to put in the y, the h and the k here, but at the same time, I want to solve for the a value that's here. So what I'm going to do is I want to pick a point that's on the graph to plug in to that because I want to solve. Now, again, what you want to use is you can just use probably 0, 0 is the easiest. So this is an x and a y. So I have x and a y, and I have h and k from these 2 points right here. Let's plug them into this, and then we can find out what the a value is, so that way we'll know what the equation is. So 0 equals a, and I put a 0 in for x, so there's 0 and 0 for x and y. Now for the h and k, both of those are -3. Put those in there. If I simplify this, I get x plus 3, or actually not x. That's plus 3 squared. So that's a 9. And I have minus 3. Add 3 to the other side. 3 equals 9a, I should put. Divide both sides by 9, and we get 1/3 is the a value. Now we want to write out our equation. So I have f of x equals 1/3. Now, when you put this in here, you're going to leave the x alone, but you do want to make sure you put the h and k back in. And so that's going to look like this. You have x minus a -3, which is x plus 3. This right here, negative becomes a plus. And then you just, plus and negative is just subtraction. And so this would be the equation of this quadratic that's drawn for us. That would be its equation. 1/3, parentheses, x plus 3 squared minus 3. That's your answer. We want to do the composition function again. As I mentioned yesterday, it's only going to ask you for f of g of x. It's not going to have g of f, so just f of g. All right, and so the g is always the inside function, so something that is inside of something else. The inside function here is going to be 2 minus 3x. Okay, so 2 minus 3x we have, that's the first part. As I mentioned yesterday, what you do to find the f is, so here is what it originally started at. We're going to take out the inside thing and then replace it with an x. That becomes now your f of x function. You're always going to do the same process for each one. Okay, so because normally what we would do is we would replace the g with the x function that we'd have. So if we're going in reverse, you replace the g with an x. So that's what we're doing here. Originally we had that, that's our g, we get rid of it, replace it with an x, and that's how you get the f of x function. All right, I didn't tell you this yesterday, but there's actually one more part of this that's going to be included, and unfortunately it's not included in the review that I gave you. There should be another question that they're going to ask, and it has to do with the end behavior. If you take a look at the sample exam that I sent you guys, I sent that out yesterday, the sample final. You'll see that on this question number 9, there's an additional thing that does not appear on the sample, and that is, it'll be a multiple choice thing that talks about as x increases, y increases, or does x increase and y decrease. You want to ask for which one of those choices it's going to be. Okay, so on the one that we did yesterday, we did this end behavior right here, and we got that. If degree is odd and a of n is less than 0, you have this. What choice that you would put for this, and this is the one I didn't talk about yesterday, you'd say as x increases, y decreases, you'd have here. So as x increases, y decreases, and you'd also have as x decreases, y increases. Okay, so that just comes from this picture right here. So why you want to definitely do the end behavior on that. That's what it's going to be asking for. As x decreases, so as you're going to the left, that's where x decreases, y increases. But then we also have this as y increases, or I'm sorry, as x increases. So as you're going to the left, x is increasing, the y is going down. So that's just the one that you're going to pick. So when you do these, that is the extra thing that I didn't talk about yesterday. that you want to make sure you know how to do, because it is included, as you can notice, it's on the that scratch work I sent for you guys yesterday. The scratch work has it on there, and so you'll just circle whatever one is there. And for these, the answer choices, I don't believe, let me just check to make sure here. The answer choices, I believe, stay static, so they don't change on this. Now it does say something like it does have infinity on there. So actually, I'm glad I looked at that now, because they worded it a little bit differently. So let's actually write this out instead. So as x approaches, negative infinity, y approaches infinity. Okay, so that's actually what you want to look at here. Now, of course, they'll have this written out for you. It'll actually say the little arrow means approaches, and you have infinity, negative infinity. I'm just using shorthand here. But on the if you look at your answer choices, you'll notice that they're all can be written out for you instead. Okay, so then the other one is as x approaches infinity, y approaches negative infinity. So as you go to the right, the graph is going down, and so that's what we put here. So that part's going to be in there for you, and the answer choices don't change for you. They're going to be the same ones that you see on the scratch work that handout that I passed out to you guys, sent out to you guys yesterday. So we're going to do that when we get to this question here. We'll actually write that out, even though it doesn't have us answer that here. We will go ahead and do that anyway. All right, so zeros, what makes each part equal to 0. So if I take x cubed and set equal to 0, I'm going to get a 0. If I take x minus 2 set equal to 0, I'll get a 2. If I take x plus 2 set equal to 0, I'll get negative 2. So these are the things that make each part equal to 0. The multiplicities will be the powers that are on each of these factored pieces. The 0 comes from the x cubed that has a multiplicity of 3. These other two, there's no power on here, so there's really a power of 1 we have on both of those. Y-intercept is where you put in a 0 for x, but if you put a 0 in for x here, the whole thing turns into a 0. So we get 0 cubed, 0 minus 2, 0 plus 2. A common mistake I'll see students make is somehow they just ignore that 0 just goes away because it's 0, and then they just multiply these and get negative 4. That's not correct. Remember, it's 0 times everything on there. So the answer is going to be 0. And so 0, 0 is the actual coordinate on that. So we know it goes through the origin right there. We also know it goes through 2 and negative 2. So those are all of our intercepts that we have. The degree is what you get if you add the multiplicities together. You get the degree of 4. Okay, now the leading term, the power function, this is your first term here. To do this, what we want to do is we're going to take each of these things that's being multiplied together. I have an x cubed. This is something that has an x in it. This is something that has an x in it. When you multiply, you're going to add the powers. These have power of 1. So we get x to the fifth. Oh, that means that this degree was not correct here. I just did, 3 plus 1 plus 1. So that should be a 5. The degree should actually match what you get on the leading term. So these kind of go together and make sure you did them correctly. So that's kind of why both of these are here. Whatever your degree is, that should be the same power that's on your leading term. That should always be the case here. Okay, so x to the fifth is your leading term. And there's a 1 that's in front of that because there's a 1 in front of the x cubed here, and there's a 1 in front of all the x's that you're multiplying together. So all those are 1s. So now this leads us to the end behavior part. Okay, so end behavior, and this is what's going to allow you to answer that multiple choice that goes with this one. And we have n is odd, because it's a 5. And the a of n is the coefficient of the x to the 5th power. That's a 1. So that's greater than 0. Because of that, if we look at the chart that we have in this section, okay, we have n is odd and a of n greater than 0. So that means that it's going to go down and up like this. So what you would put for the answer on this is as x approaches infinity, y approaches infinity, and also together, this is all one answer here. We have as x approaches negative infinity, y approaches negative infinity. That's the answer choice that you would put on that. So again, they don't have these symbols in here. It's all kind of written out for you instead, but you would just select the one that describes this. Now, because of that, we now know how to graph it because it's giving us enough information to do so. So first of all, I know that the graph is coming up from the bottom. And what I also know is these multiplicities are all odd. So because they're all odd, that means the graph is going to cross at all 3 of these places. So this comes up here. It's going to go up to a certain amount, and then it's going to curve and come down. Now, one thing to note about this is where it crosses at 0, that's coming from an x cubed. So because it's a cube, we have to make this look like a cube when it goes through. So we want to put a little bend in the graph like this. There's a bend in the graph because that's an x cubed. If it was just x, then it'd be like a straight line. But when you have cubes, you have to kind of draw them that way. So we're going to have a little bend in the graph like that. It's going to go down to a certain amount, curve, and then it's going to come and go back out like this. So that's what your graph is going to look like. We don't know exactly how high or how low it goes. Again, this is going to be a multiple choice situation anyway. So you're just going to select the right one on there for the myOpen Math. Okay, so just select it from there, but that would be it. We want to use synthetic division. So again, just a reminder, you want to definitely use the factoring method on this. So factoring, you must use here. So I need to see synthetic division, and I also need to see factoring. It says specifically use both of those. So don't use quadratic formula. I need to see factoring in order to get the answer. Okay, so specifically these 2 things you have to use: synthetic division and factoring. So 4/3 is a 0, which means that we'll put that in here. Okay, so we're going to do that first. As you notice that both of these examples are both the one I did yesterday and this one, they're both cubes. That means that's the one you'll get on the test too. It'll be a cube. So you're only going to have to do synthetic one time on this. Bring down the first one, 27, or multiply 27 by 4/3. So you can do that in a calculator, or 27 and 3 reduces to a 9. And so then you're going to get a 36 out of that. Add that together, it's going to give you negative 18. Negative 18 times, so I'm going to write this out just to show you what we're actually doing here. We multiply this, you can divide out both of those, and that's how we get 36. And then if you do the 27, or 18 rather, 18 over 1 times, I'm ignoring the minus sign, of course, and just showing you the reducing part. That reduces to a 6 and a 1, which means that's going to be a 24 and a half. But of course, it's going to be negative 24 because we do negative 18 times a positive. That's going to give you a 3. When you multiply this, the 3's will cancel, and you'll just get a 4, so you get a 0. Now, if you don't get a 0, that means you want to go back and check your work. That means there's something you did wrong, because they're always going to give you a number where you should get a 0 as the remainder. So if you don't, then you made a mistake. Go back and check it. What we have left now is 27x squared minus 18x plus 3 equals 0. It says to solve this by factoring. So the first thing I'll note here is there's a common factor that I'm going to pull out. So I'm going to pull out a 3 and I get 9x squared minus 6x plus 1 equals 0. But then this is one more thing I can factor. All right, so this definitely trial and error would be easier here because there's only a couple factors of 9. There's only one factor of 1. So there's not a whole lot of options to guess and check here. So we can do that pretty quickly. 3 and 3 are going to work. If you make both of these negative, 9x squared minus 3 gives you the minus 6, and then plus 1 when you multiply those. We're going to set that's equal to 0. Now, of course, you can't set 3 equal to 0, so that's not going to give you a solution. But if you do 3x minus 1 equals 0, then you're going to get 1/3. In fact, that's the only number that you're going to put here. Okay, so it says find the other zeros. So the other zeros means you're not going to include the original given 0 on that. You're just going to put 1/3 on that one. Okay, that's going to be it. You don't have to write 1/3 twice. If you get a repeat one, just write it once. Then we come down to our calculator-based question. 4 decimal places is what it's asking us to round to. So these you're just going to put into your calculator. Again, this button, you're using the one that's above the LN button. You got to use for this first one. Okay, so make sure you have a scientific calculator or graphing calculator you can use as well. Okay, so you have to hit a shift key or a second key to get that top one. I'll just give you the answer on this. You can check it out on your calculator on your own. Okay, so this here, you should have an LOG button that's on your calculator. So you want to use the LOG is a log base 10. And so you'll use a base. So for this, you'll use that button. So there's no number underneath. That means it's a base 10. So you can put 3 divided by 11 on your calculator first, then hit the log button, or you can type it in all at once like we see here. Either way, you should get 1.0498. That's what you'll get for that decimal. I'm sorry, I gave you the wrong, these are the answers from yesterday. Okay, so this is actually going to be instead, sorry about that. These are I looked at the wrong numbers down here. 1.0395 you get for that one, and this is negative 0.5643. So that's the answer on that. So 1.0395 you should get there, and negative 0.5643. If you have a decimal inside here that's less than 1, you should get a negative on your answer. That's why when I saw that I was kind of suspect and wondering what was going on there. There should be a negative because this number inside is less than 1, which means you should get a negative answer whenever that occurs. Okay, we're solving. We want to put this into exponential form, but we're not solving here because it says do not solve for any unknowns. Okay, so this is a log base 10 is what that can be changed into. A log with no number, it's always a base 10. So we want to do 10, the base, raise the number after the equal sign. The base raised to the power of 6 is going to equal 2 minus 7x. And that's it. That would be your answer. Okay, so nothing more to do there. This, we're going to do the similar thing. We're going to do 13. Raise the number after the equal sign. 13 to the power of x equals 60. Nothing to solve here. You're just changing it into the exponential form, and that's it. That's all you have to do. Number 13, we want to change this into the log form. The fraction is going to be the base of the log. Then we have so that's what we start with first. The 3 is the number that goes after the equal sign. Whatever you have left is going to go inside the log. You can either leave your answer like that, or if you'd like to switch it and do Log base 1/3 of 1/27 equals 3. If you put this into my open math, they will put these parentheses there for you. So you do have to put the parentheses around that. Otherwise, it won't like, it'll say some kind of syntax error or something like that. It'll say, so you do need to put the parentheses on that. All right, so 14b is going to have 3 parts, 1 log, and then 2 exponentials you're going to solve. This has the one we did yesterday had a minus sign in it, so now we're going to do one with a plus. You want to make sure you know how to do both kinds, either a minus or a plus. So let's do the plus one next. First, we're going to take these 2 logs and put them together as multiplication. Okay, so we multiply. The plus means multiplication. Now we're going to change it from log form to exponential. The base, raise the number after the equal sign, equals everything inside the logs. That's the next step. 2 to the 3rd power is 8, and then I can multiply this together. 2x squared minus 5x plus 10, minus 5 plus 10 is 5, and minus 25. Okay, so next thing we want to do is subtract it and get it equal to 0. Okay, so that's the next step. Quadratics, you always need to set them up and set it equal to 0 always. Now we're going to do some factoring. Put the 0 on this side. 2x, there's only one way to do that. 2x and x, that's it. 33, not a whole lot of options here. Let's try 3 and 11. Okay, we want to get a 5 in the middle, so 20, that's too big, so let's switch the order on that. Let's put 11 here and 5 there instead. Yeah, this will work. This is 10 and 11. So 10 and 11, if I look at the, I'm sorry, that's going to be a 3, not a 5. What am I doing? 3. Okay, so 3. Okay, so this is going to give us a 6 and 11. We want to get a 5 there. So this will work if I put a minus here and a plus right there. Then I get 2x squared minus 6 plus 11 is a 5, and then 11 times -3 is -33. That does work out. That's how I knew that that's why you should always multiply this kind of out in your head to make sure that works. I had that error there before. I accidentally put a 5 there instead of a 3. So when I multiply, that wouldn't make any sense because you're not going to get the 33 in the end like you're supposed to. So that's why when you factor, it's always good to do a little mental multiplication just to make sure it actually does work. Set both these equal to 0. 2x plus 11 equals 0, and you're going to get -11 halves. And then if you take that x minus 3 equals 0, you get x is equal to 3. Now I want to test both our answers. You want to put these back into the original log, and you want to make sure that you don't get a negative number inside. Now, -11 halves is the same thing as -5.5. -5.5 plus 5, that's going to give you a negative number. And if you put that in here, it's a negative number. So this right here, you have to cross that out. That one doesn't work. Okay. You put 3 in here, 3 plus 5, positive. 2 times 3 is 6 minus 5, that's positive. So 3 is the only answer you have. So for log problems, you always want to make sure you check your answers that you get to make sure they work in the original one. Next, we need to isolate with one like this, you want to isolate the term that has the exponent in it. So I need to add 21 to both sides. So if I do that, get 27 on the right-hand side. Now we want to write both of these as the same base. This is going to be done by equal basis property. Don't take ln's of both sides. That's not the way you want to do that. You want to use properties of log specifically in order to solve this. On the last test, If you didn't use property of logs, you got credit taken off, because specifically you want to use properties of logs to solve this. So don't take ln of both sides. That's not the process I'm looking for. Got to use the process that I'm showing here, equal basis property. Okay, so by doing that, you're going to change this into 3 cubed. Okay, so we got the base is 3, and then since the bases are equal, we're going to set the exponents equal to each other. We get that. We're going to subtract 1, so we get negative 2x equals negative 4. If you divide both sides by negative 2, if you do that, I'll just write the answer. X is equal to positive 2. Okay, so you get that on that one there. Oh, you know what? Sorry about that. Again, apologize, made another mistake again. This is 2 here. So subtract 1 from both sides, that's a 2. So if you divide both sides by negative 2, you get negative 1 is the right answer. Sorry about that. Negative 1 is the right answer. E to the x equals 4.5. Okay, so because it is an e, this is the one you do want to take the natural log of both sides, because this one you can't use equal basis property here. ln and e is going to cancel out, and you're just going to get x equals ln of 4.5, and it will say on the test to round your answer to 4 decimal places. So if you do that, you get 1.5041 by just putting that into the calculator. So you're going to do ln of 4.5, and then you'll get that decimal 1.5041. All right. The last one that we have here, we want to use we got the systems of equations on that. So this again it'll be one linear, so you're not going to see any x squares or anything like that, all linear on this. You can solve it by either using substitution or elimination. Now, yesterday I did elimination method, so I'm going to show you this problem with substitution. We have a little bit more with the fractions going on here, but I do want to show you that just so you have another example of it. So let's suppose we want to do this one by substitution. Then what I would do is you can take either equation and solve for either x or y. I'll just go for the bottom equation since there's no negatives there and solve. I'm going to solve for the y. Dividing by 2 is pretty simple, so we'll do that. Might be a little easier to do it that way. Let's isolate the 2. You're going to get negative 6x plus 1. Divide by 2 there, you get y is equal to negative 3x. It's supposed to be 3, negative 3x plus 1/2. So now, since we use the bottom equation, we want to go into the top equation instead. So we're going to put this into the top equation. So 4x minus 3 times negative 3x plus 1/2 equals 5. Okay, so notice what I did there. I solved for the y in the bottom equation, and then now we put it into the top equation. You don't want to put it back, use in the bottom equation a second time, because if you do, you're just going to get everything to cancel out. So we don't want that. Okay, so instead, we will put it into the top equation. 4x plus 9x, then we have minus 3/2 equal 5. If you don't want to deal with the fractions, you don't need to. You can just multiply both sides by 2, and you get 8x plus 18x. Then we have the 3's will cancel, minus 3 equals 10, just like this. So in that step, we've eliminated the fraction by going through that. So now if you add that together, you're going to get a 26x minus 3 equals 10. Come on, pen keeps glitching out here. Okay, so we got 26x minus 3 equals 10. We're going to add 3 to both sides. 26x equals 13. Divide both sides by 26, and we get x is equal to, so because we're dividing by that, we're going to get a 1/2 for the answer. Okay, so that's the one part of the answer. That's our x value. But now we want to find the y value. Now we already did find the y value earlier. We have y equals negative 3x plus 1/2. So I'm just going to put the 1/2 into here. I have -3 times 1/2 plus 1/2. And what we get from this, you get -3/2 plus 1/2, that's -2/2, or -1 as the answer. So 1/2 and -1 is what you get for the answer. Okay, so that's another way that you can do it. We could have just as easily have done this with elimination method. Elimination method, I believe, is easier in my opinion on these problems, but again, you do have a choice to do either one, and it doesn't matter which method you want to use to solve. You can either use elimination method or the substitution method. I just want to show you one example of each. Don't do the graphing method. Graphing method is one thing we did talk about in this class, but you don't need to use graphing because they're not going to ask you for a graph. And also, if it was a 1/2 or something like this, graphing might not be as accurate to get your answers. I would stick to either substitution or elimination in order to get this one. All right, well, that is all the questions on the test. And so your final exam is going to be tomorrow, July 28th, 2022. And so you have all day to take it. And if you have any questions, please let me know. It's been my pleasure teaching all of you virtually this summer. And enjoy the rest of your summer, and best of luck in your future endeavors. Just a little heads up, I will be emailing each one of you individually about what your overall grade is going to be in the class, and also what your final exam score is. So be patient. It will take me a couple days to do this, so you may not get an answer. You may not even get an email possibly until Sunday. I'm hoping to get all of them done, no later than that, or definitely before that time. And so hopefully all of you will receive. You'll know what your grade is, and you'll have your final exam score will be adjusted. I'm automatically going to add in. You'll also see, by the way, that I'm going to add in the points. And so I add in the extra credit. And so the score that you're going to see in an email that I send you will include the bonus points, the bonus review assignment. It's going to include as well. So of course, I can't grade your final exam until you actually complete the bonus review. So if you want me to start, grading that earlier, then go ahead and you can even finish it by today, for instance. That way tomorrow, if you don't have your final exam complete, I'm going to wait until probably Friday to grade it, because that way I'll know that you would have done everything you can. But if you have 100% on it, I'll just go ahead and add that, and I can get what your overall score is going to be in the class. So I'll do that for you guys. I'm not going to turn grades into CSM probably until Tuesday morning. So that way you have a couple days to email me in case you have questions about your overall grade. So that's going to be it. Any questions we have now? Thank you. Thanks for that comment. Appreciate that. I'm glad you enjoyed the class. So, all right. Well, we'll go ahead and end this meeting. Best of luck to all of you. God bless.